Why? Really? Is this shit happening?
Alright man, whenever you're ready.
Hi, I'm Ashish Rastogi. We're going to talk about finite random variables in this video. So here we go. Finite random variables is the introduction to a type of content that in this class that'll take a little bit of time to understand. So I want you guys to make sure that you don't go too fast through this, because the rest of this class will build off of this information and more information that we'll get into in the next video. So make sure you understand this very thoroughly. So finite random variables, start with what that means. So you have two types of finite random variables that you can work with. You can either have a PMF or you can have a CDF. And a PMF might be described as, may be shown as two different things. It can either be shown as a little f of x, or it can be shown as a probability that x is equal to x. So you've seen these before, but you may have not known exactly what they meant. So now we're going to get into exactly what these things mean. And then over here, CDS, I'll just write this real quick, is a big F of x, the capital F. And you can also see this written as a probability that big X is less than or equal to x. So this one is a completely new concept, and this one is a concept that you've been using but haven't really been realizing that you've been using it. So let's start with something that you've seen in this class. You've seen this chart. You've seen a chart like this where they say, here's x and here's little f of x, or sometimes this column is also shown as a probability that big X is equal to x. So we're going to make a chart like that. And what we'll do is we'll do 1, 2, 3, and 4 for x. We'll do 1, 2, 3, and 4. And we'll give this one the probability 0.1, 0.3, 0.4, and 0.2. And we know that's right because these should add up to 1.0. So that's right, because these probabilities add up. So in this context, this is your x, these are your variables, x, and these right here are your probabilities. And these are also known as your PMFs. So PMF stands for probability mass function. This is going to tell you the probability of exactly 1 point. So the probability of exactly 1 occurring is 0.1. The probability of 1.01 is 0, because that does not exist. It's not one of these possibilities. So even if it said the probability of 1.9999999 repeating forever, it would still be 0. It would not be 0.3, even though it's really, really close to 2. So let's talk about CDFs. This is the part that gets a little bit more confusing. So this can be represented as big F of x, this next column over here. So let's talk about what a CDF is. Cumulative distribution function. So a cumulative distribution function, what that huge word means is that it's going to take your first probability and it's going to continue adding on top of that probability as you go further down the x-axis. So you know that when you have an when you have a graph, your bottom axis, your x-axis, is your x variable, right? So as you move in this direction down the x-axis, as you move to the right, you're going to continue cumulatively adding probabilities of all your possibilities. So let's start with the CDF of 1. So if you notice this guy right here, it says the probability of x equaling that x value or anything before it. So it's very important. It says anything before that x. So if you're looking at this, the way you should interpret it is that the CDF of 1 means the probability of 1 and anything that came before 1. Well, since 1 is your first possibility, that means that there is nothing that came before 1. It's just 1. So the probability that you get 1 is going to be 0.1 for this CDF. So you start off the same. So now let's get to the hard part. The probability of 2 or less. That's what this means. So when you say the CDF of 2, what you're really saying is the probability of 2 or less. So the probability of 2 or less, well, here's 2, but this is also less than 2. So you're going to add these two together, you get 0.4. Moving on, you get the CDF of 3. The CDF of 3, you interpret that as the probability of 3 and less. So here's 3, and here are two values that are less than 3. So you add all of these together, and you get 0.8. You do the same thing with 4, probability 4 and less. That's all the probabilities of 4 and anything that came before 4, and you should get 1.0. If you do not get 1.0 at your end value, so the last value of the CDF, it has to be 1. If you don't get that, then something went wrong. The last value for the CDF should always be 1. So let's kind of explain what this means on a graph. So let's start off by graphing how the PMF is supposed to look. So we started with 1, so we'll have 1, 2, 3, 4. So 1, 2, 3, 4. And we'll have to graph this. So you note that a PMF should be a bar graph because it's describing exact points. So you draw a graph right there, and this will be 0.1. Then we go to 0.3. And then 0.4. And then back down to 0.2. Okay, so this bar right here represents the 1. This bar right here represents the 2, and so on, right? So this would be the appropriate graph for the PMF. So let's see how that changes when we do a graph for the CDF. So it's still going to be a bar graph, but it's not going to be the same bar graph. So you're going to actually graph these numbers over here. So we're going to start off with 1, sorry. 0.1. So the CDF of 1 is 0.1. The CDF of 2 is 0.4. Oops. Then 0.8. And finally 1. So there's some characteristics here that you should notice. First, you notice that the PMF can go up and down. It doesn't matter where. And it's always going to be a probability less than 1. That's what the rules are for a PMF. Those are the two things. It can go up and down, and it'll always be a probability less than 1. Over here we have a CDF, and so we'll do a CDF right here, and then the X values. So here, the properties that you should know for a CDF is that the CDF will always increase, and it'll always go up to 1. It'll never exceed 1. So it'll never decrease on the CDF. It can never go to 4.4 and then come down. And it'll always end at 1. So that means it has to increase. If it does not increase all the time, then something went wrong. What you should keep in mind, though, is that when you say that what the height of the CDF is referring to, right, this 0.4, this height, 0.4, is referring to the addition of these two numbers right here. Right, so that's what you'll need to know. And this is going to be more important to understand when you go into continuous random variables, which is the next video.